All right, I'm back for the HL portion. Okay, so again, as usual, for the sake of time, I am not going over questions that appeared in the SL exam, so go watch that. And then just looking through the exam, there wasn't even that many changes to the SL questions. So our first HL question is actually just going to be this one. Okay. So consider this function. Sure. Show that it's an odd function. Okay. So by definition, an odd function means that, depending on how you write it, then if you were to take the positive x side of your function and then reflect it vertically, this is what the negative x one looks like, or something. I don't know. You just need to show this. So that's what we're gonna do. Okay, so part A. On my left side, I'm going to have minus 2 to the power of x plus 1 to the power of 2, 1 over 2 to the power of x. And on the right side, what do I have? I have 2 to the power of negative x minus 1 over 2 to the power of negative x. And then these are just going to be negative exponents, so they're reciprocals. This is 1 over 2 to the power of x. And then this is a reciprocal of a reciprocal, so this is just 2 to the x. And then very clearly you can see that the left side is equal to the right side. Okay. Then you got a different function. Solve this inequality. Okay, that's kind of out of nowhere, but okay. Okay. So if you think about what this is saying, sorry, need to turn down the music for me. So if you think about what this is saying, I don't even know if this music's too loud for you. Hold on, I'm gonna turn it down a little bit for you. What this is saying when is f intersecting, this is when they're equal or above g, right? F being greater than means that it's going to be above it. So we can just graph the two and then look at the graphs. So got Desmos. And then my first function was 2 to the power of x minus 1 over 2 to the power of x. Okay, and then my other function, 1x minus 1 over, what the heck? Okay, x squared minus 2x. Minus 3. Okay, and then some things to note. This function g has some two vertical intercepts, one at -1 and one at 3. So I'm just going to add those in. Hold on, and then let me just choose nicer colors and thicker lines for the sake of demonstration purposes. Okay, so as you can see from this graph, we want the red graph to be intersecting or above the other graph. Hold on, I did not type this in right. There you go. Okay, we want the red graph to be above the blue graph. So as you can see, there is one section to the left of our first x-intercept. So from negative 1.27 to basically 1. So inclusive 1.27 to 1, negative 1. Exclusive, because we actually don't have a value for g here. And then we are going to combine that with our other ones. So I'm just going to union this with the other intervals. The next interval is right here. So at 0, 1, 7, 8. And that's an inclusive one. All the way till our second intercept, or asymptote, which is 3. Exclusive. Or you can use the reverse square bracket, or you can use inequalities if you want to. And then we're going to union this with, if you zoom out, they will intersect one more time here. 3, 0, 6. And I think this just goes to infinity. So there are all the places that I have my red graph above my blue graph. Not bad. Okay, we got two vectors. So here's the first vector, and then I know the length of the second one. And then find the possible range of values for the length of A plus B. Okay. So I helped a student in physics with a very similar question. So fortunately, this one's not quite that blind. But first we should find the length of A. So this is going to be 12 squared plus 5 squared, more or less. Which, for those of you that don't know, these are actually Pythagorean triples. And it's going to be 13. 5, 12, and 13. Like 3, 4, and 5 are Pythagorean triples. Okay, so you want to find the range of values. You have no idea what direction B is pointing at. So if you think about it, the largest the magnitude of their sum could be is if they ended up going in the same direction. In which case, the biggest their vector magnitude, the magnitude of the sum of their vectors would be 13 plus 15. So that's my maximum, is 28. And then the smallest it could be is if they were going in opposite directions, which means that this is going to go this direction, 15. So their resultant vector just has a length of 2. So your possible range of values is from 2 to 28. Okay. And then consider the vector p. So p is going to be a plus b. Given that b is a minimum, find p. Okay, so the minimum is 2. Then we need to find p. Okay. So I think, well, I need to find the vector b. Okay, so p. I'm going to say that b is going to be have the coordinates x and y. From here, we know a couple of things. First off, I know that the length of b, magnitude of b, is 15. That was given. So this is x squared plus y squared. And then I can write p in its whatever they're called. I want to say compartments, but it's not compartments. Sorry, this is it's like 1 a.m. in the morning, and I wanted to get this done. And I already went through the SL one, so my brain is a little tired. Anyways, the components. So it's gonna be 12 plus x, and then negative 5 plus y. So that's p. And then we know that the length of p is a minimum, which means that this stuff is going to be equal to 2. So we have a system, so I guess I'm going to solve it. Both of these are disgustingly ugly, so I'm just going to square both of these so that I don't have a square root. So I'm going to get two new systems. 15 times 15 is 225. I'm like 90% sure it's 225. And then we get our second equation. 4 is equal to 12 plus x squared time plus whatever. And I'm going to continue simplifying the second one, because if I do, I will eventually get an x squared plus a y squared. So I can substitute in the first formula, and then I can see some problems arising, but we'll take care of it when we get there. Okay. So like I said, if you see x plus y, you can substitute it with 225. So this, substitute with 225. So I got 4 equals 144. And then I'm just going to write the 225 right here. Okay. And then plus 25 plus 12x minus 10y. I don't, do I want to add these up manually? Nah. Okay, 144 plus 250 is 394. I really hope my arithmetic is right. Ugh. Oh well, okay, so then I guess this means that negative 390 is equal to 12x minus 10y. Before I continue, I really want my numbers to be right. What I saw is 144. Aha, this should be 24. Sure, whatever. Okay. So this is 225. 225 plus 25 is 250. 250 plus 144 is 394. Sure. Subtract it from 4. 4 is 2 squared. Sure. Let's just say that this is right. Okay. So how does that help me get y or x? I guess I could solve for x or y, and then can I put it back into one of these? Would that be circular? And also, this is only 2 marks. Oh well, okay. I'm gonna just try this out. Normally I don't like plugging things back into equations that I've already used to plug into other things, but maybe it works out. Usually it doesn't though. So 24x is equal to negative 390 plus 10y. So x is negative 390 plus 10y over 24. And then I'll just use this equation right here. So 225 is equal to that stuff squared plus y squared. And then we are going to solve by GDC. And pray that this works. And I know I should care more about HL math, but I don't. So I really do hope that this is what you're supposed to do. And if it's not, or if there's an easier way, let me know in the comments, respectfully. These are such ugly numbers. What the hell? Okay. So my y component is going to be 5.9 or 5.77. Okay. And then we got 225 minus the y value, 5.77 to the power 2, and then we square root this. So my x value is going to be 13.8, I guess. Let's do the wiggly so that we know that we're rounding. Sure, okay. So then therefore P is going to be this. So we're going to have 12 plus 13.8, which is going to be 25.8. And then from there, y is going to be 0.77, it seems. Sure. Okay. Can't believe that's 2 marks. There's gotta be an easier way. Okay, consider vector q. Okay. And then find q so that it's the same length as b, but it's perpendicular to a. Why is this one 5 marks? Okay. Because if it's perpendicular to A, then Q should be the direction vector for Q. It should be some multiple of the negative reciprocal. So 5/12, right? Okay. But we know that the length of this is 13. So what we do is we find its unit vector, which means that we take this and basically multiply by a scalar 1/13. So now it's a length of 1. And then we need it to be the same length as B. And B is 15. So you just multiply your unit vector by 15. This is suspiciously too easy. I can't really think of another way to do this. Or rather, I can't see why this is wrong for now, but maybe it is. And maybe this isn't worth 5 marks because it's harder than that. And this was easier than I thought, and it should only be 2 marks, but this doesn't look like 2 marks to me. Whatever. Again, I hope you guys are watching this after the SL, because I left a little disclaimer about, you know, the context of these videos. Okay, consider this equation, blah, 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 blah. Write down an expression for the product of the roots. Okay, so you do have the product of the roots formula. So product of roots is -1 to the power of n of a naught divided by a n, I think. Pretty sure. Okay, so then that means that we have, because this is squared, this doesn't matter because it's positive. And then a naught is this thing, 2k plus 9. So we have 2k plus 9 divided by k. Okay, and then, I don't know, I guess we can simplify this. 2 plus 9 over k. Okay, hence or otherwise, determine the values of k such that the equation has 1 positive and 1 negative real root. Okay, so if we know that this is their product, which means that you're multiplying them together. And if you're going to multiply a positive and a negative together, it's going to become a negative. So this means that this is negative. So you're essentially just solving this inequality, right? Solve for k. So 9 over k needs to be less than -2. Which means that there's lots of ways to solve this inequality, but I'm just going to take the reciprocal, which would flip the inequality, -1/2. So k needs to be greater than -9/2. Sure, that was pretty easy. Next up. Oh, this looks like combinatorics. Mary, 3 female friends, and her brother Peter go to the theater. There's 10 empty seats, and then for the first half of the show, they decide to sit next to each other in this row. Find the number of ways that 5 people can be seated in this row. Okay, this is pretty straightforward combinatorics. Okay, so you got Mary, her 3 friends, and Peter. So they are going to sit together next to each other. And then you also need to arrange the empty seats. So there's also 5 empty seats, right? So 5 empty seats. And when you want things to be together, then you essentially treat them as one item in your permutation. So what this is this is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 items or seats or whatever you want to think about it, or you need to arrange them. So this is 6 factorial. But within the group, they can sit in whichever order that they want. So there's 5 people in this group, so we need to multiply the arrangement of your items with the arrangements of the group. There's 5 people in the group, so multiply this by 5 factorial. And then I'm just going to leave it like that. Okay, part B. For the second half of the show, they return. Okay, same seats. The 4 girls decide to sit at least 1 seat apart from Peter. What did Peter do? The 4 girls, however, they don't need to sit next to each other. Find the number of ways these people can now be seated in this row. Damn, what the hell did Peter do in the first half of the show? Okay. So if Peter sits at the end of it, then you need to make sure that there's an empty seat. And then afterwards, you have 8 other seats, right? And because there's no particular reason or way for the girls to sit next to each other, then what you're doing is the number of arrangements where Peter sits on, let's say for example, the left side, this is 8 factorial. You basically just need to arrange these ones. Obviously Peter can sit on the other end though, so your total number of arrangements of everybody, if Peter sits on one of the ends, is 8 factorial times 2. 1 for the left side, 1 for the right side. Okay, and then if he doesn't sit at the end, so not at the end, then what that means is that there's going to be an empty seat on both sides of Peter. And then you essentially have to fill in everywhere around him. Oh, so then this just becomes a grouping question again. So basically, you consider Peter, empty has to be a thing if they're not at the end, right? If he's not at the end. So just like this question, we're just going to consider this as a group. And then that takes up 3 seats, so then there's 7 others, which includes the empty seats and then her friends and herself, Mary. So we are arranging 8 things. Peter's empty chair group and then the 7 other ones. And then of course, there's no arrangement of this. This has to be empty Peter empty. So I don't need to multiply this like this example, I think, by this. Okay. And then you just add these 2 together. So if you have 2 times 8 factorial and you're adding another 8 factorial, then your total is, I mean, this is kind of a not how you would write it, but that means that you have 3 8 factorials. Yeah, this seems about right. Okay. Tricky, but not too bad. Okay, consider this function from 1 to 2, sketch the curve. Okay, that's nice. Indicating coordinates of the endpoints. Sure. Well, this is just GDC work, right? Okay, 1, 2. All right, time to punch this into graphing calculator. So what was it? Square root of x squared minus 1, I think. Okay, and then we only want this between 1 and 2. So at least with mine, I can restrict the domain. If not, you can just find the individual values of the function at 1 and 2. And then you get this tiny little thing. So you have a x-intercept right here. And then you have an endpoint at 1.73. So somewhere here, I guess, and then it goes like that. And I guess I'll just label this. Okay, there you go. 2 marks. Show that the inverse is going to be this. Okay, sure, we can do that. Algebraically find the inverse. So this is y, and then we switch x and y. Can you guys see that color against that? Yeah, that looks pretty neon, at least on my screen. That's showing me what's being recorded. Okay, square both sides. X squared is equal to y squared minus 1. Square root both sides. Oops. And then there's going to be a plus or minus. Or oops, no. Don't square root both sides just yet. Add 1 to the other side. Now you square root it. And then there's positive and negative. And so we are obviously going to choose the positive version because your domain of your original is positive. Therefore, your range needs to be the positive one because it's the same as the domain. So then this is going to be positive square root x squared plus 1. Okay, state the domain and range of the inverse. Okay, so the domain of the inverse is equal to the range of the original, and then I don't know if I can use an equal sign here, but whatever. And then this is 0 to 1.73 inclusive. And then the range of the inverse is the same as the domain of the original function, which is from 1 to 2, as they told you in the beginning of the question. Okay. Then the curve is rotated about the y-axis to form a solid. Show that the volume... Oh. Okay. Okay, I'm gonna borrow this graph. So you rotate this about the y-axis and you make like a weird like vase or vase for water. Now the only issue with this is this is a rotation about the y-axis, which you technically don't know how to do. Because what you would do is you would take the integral from 0 to 1.73 of basically, how do I explain this? You're HL, so you kind of know how this works, but this is going to be pi r squared, which is the rate, like you're basically doing the area of the circle and then you're adding a bunch of them together. But your radius is going to be your x values. So your radius is x, but you're integrating this with y. So it's a little different than your normal one, your normal area or solids of revolution. Now, I already know how to do this because a couple of years ago, I helped one of my students with their final calculus exam. And you're supposed to use the fact that you have the inverse. And we're actually, and then knowing that the inverse is just a reflection of your original one. Okay, this is your inverse. And if we're just talking about volume of a solid, this volume, which is a rotation about the x-axis, because we're using the inverse, it's going to have the same volume as this. So it makes way more sense to do this integral, which again is the integral from 0 to 1.7, yeah, 1.73 of pi, and then your radius is now your actual y values, so you can just square your inverse. But luckily they already gave you that as a function. So we're just going to evaluate this integral. Oh, nice. We're going to square root as well. Not that it even matters, because you're just going to GDC this thing. So integral from 0 to 1.73 of pi, and then I think it's just x squared plus 1 dx. So 10.9. Again, real important that you realize this, because technically you guys don't know how to integrate these. Well, I mean, conceptually, yeah. Like, you need to find out what your radius is as a function of y. And your radius is x. So you need to find x as a function of y, which is literally the inverse. And that's another way to think about it. Okay. Then what's next? Hence determine the maximum volume of the container. Okay. Oh wait, hold on. I messed this up somewhere because I'm not supposed to get an actual answer. I'm supposed to get a function. Oh, okay. Well, I guess we're just gonna do the indefinite integral. Why are they doing that? Okay, so what the heck is this gonna be? Looks pretty good. I just don't have this. Oh yeah. Oops, I messed up my integral. Okay, and then we need to find C, but obviously we have some initial conditions because the volume when x is 0 should obviously be 0 because you don't even have a vase anymore. And then that obviously means that C is 0. So there you go. That is the equation of your thingy. Of course, and then this is in terms of my inverse, which is going to have my variable x, and then of course the actual vases with a variable y or h. So yeah, all you do is you just change the variable name to h. Okay, and then hence determine the maximum, so just GDC this. So pi 1 over 3 h squared plus h. Now your height has some limits here. Your height is basically your y. So I think we do need to follow the range of your original function. So let me just make sure that this is specifically for our range, which is 1.73 or so. Wait, why? This is stupid. You don't, because wouldn't it just be the most at the highest height? Because then you have the most vase available, or vase. Yeah, sure, whatever. Okay. Here it is. At you get a volume of 10.9. Hey, didn't I find that out earlier? I forgot. Because I did basically take the integral from 0 to the max height, which should give me the max volume. Okay, sure. Oops, accidentally did the question. Okay, at time 0, container is empty, duh. Oh wait, no, not duh. This is just, they're gonna drip water into it? Sure. Okay, so find the time it takes to fill a container to its maximum volume. So this is your volume. So the time it takes is going to be the volume divided by the rate. So 10.9 divided by whatever the question said the rate was, 0.4. This is the last question. I think there's one more. I want to go to sleep. Okay, 27.25. And what's the units? Seconds? Okay, and then this is an exact answer, so I don't necessarily need to round it, I think, to 3 significant figures. But you could, and I don't think they'll take off marks for it. Okay. And then find the rate of change of the height of the water when the container is filled to half of its maximum volume. Okay, so now we have a related rates problem. So let me just rewrite the formula for your volume. Okay, and then what we're going to do is we're going to take the derivatives with respect to t. So this is going to be h squared with a chain rule of dh dt plus dh dt. Okay, and then what they did tell you is they did tell you that this is how much water is being added. So this value is your dv dt. This is the change in your volume. So I know that dv dt is 0.4. And then essentially I need to find out what h is, and then I'm gonna solve this like a variable. So hold on, let me just isolate slightly. So pi, if I factor out the dh dt, I'm gonna get h squared plus 1. So dh dt is going to be basically 1 over pi times h squared plus 1 times dv dt. And again, I need to find out what h is, and then that is why they told me this is when the container is filled to half its max volume. So its max volume is 10.9. So half of that is 5.45. Okay, so V is 5.45, and then from this I can find my height because I do know this formula. So thank goodness I still have it here, but I want to find out when this is going to be 5.45, and that will happen at a height of 1.18 using GDC. Okay, so that means that dh dt, which I'm assuming that's what we were finding. I didn't even read the question. Yeah, find the rate of change of height. It's the only other rate of change in the equation. Okay, dh dt is equal to 1 divided by pi plus 1.18 squared plus 1 times 0.4. Still one more question too, and I bet you it's the hardest one. 1 divided by pi 1.18 squared plus 1 bracket bracket times 0.4. So 0.0532. And then if you want units, meters per second inverse. Yeah, there you go. Probably something like that. No, there is one more. Okay. Differential equation. Euler's method? What the hell? Give me a second to remember what Euler's method is. Newton's method is finding x-intercepts. But I think, yeah, oh yeah, this is similar, okay. So Euler's method is used to approximate y with linear approximation. So before we start, just like if you have an equation for the gradient, then what you do is, like, let's say this is f, and then you do know a starting point kind of close to what you want to find out, like here. Then first you find the equation of the tangent line at the point you know. And then what you do is you take steps towards the thing that you want. So in this example, we're moving 0.1 at a time from 1 all the way to, and we want to approximate at 1.5. So then you can get a coordinate, because you're going to get the equation of the tangent line. You're going to get a coordinate on the linear graph. And as you can see, it's fairly close to the actual function. And then all we do is we just repeat this process. Now we find the tangent line at this one. Ugh, let me draw that better. And then you go 0.5 of a step later, you find a point on this tangent line, and as you can see, it's still close to the actual function. And then we just rinse and repeat. Take another step, find out what coordinate find out the coordinate on the linear line, then take a thing of that, and then we keep going until we get a decent approximation. And as you can see, there is like room for error, but it's pretty close. So we're gonna just do that. I have to do 5 times, man. Okay, hold on. I need room for this. I need to know this equation. This means that this is going to be y squared over x squared minus 2. If I just divide this by x squared. And where am I starting? I'm starting at x1. Okay. So x is 1 and then y is 3. Okay, so the slope at this first one, or gradient, is going to be 9 divided by 1 squared, so 9 minus 2, which is 7. So our first line line 0 is going to be in point gradient form. Y minus 3 is equal to 7 bracket x minus 1. Okay, then we're going to take a step. So this is P0. So that just means that P1 is going to be at 0.5 essentially, because I'm going to do 1.5 in this formula. And then this is going to be plus 3 over there. So y is equal to 3.5 plus 3, which is 6.5. So this is my P1 is 1.5 and 6.5. This is disgusting. I have to do this 4 more times. Okay. This means that the slope of my second line, which I'm going to call M1, is going to be, what was it, y squared divided by x squared minus 2? Yeah. .5. I wonder if there's a calculator function to speed this up. Euler's method. I mean, it's simple, it's just tedious. Yeesh. 16.7 slope? That's a big increase. Did I type it in properly? Yeah. Okay, so line 1. Y minus the 0.1, so 6.5. Actually, I'm gonna write this on the other side to help with future calculations. Or sorry, this isn't 1.5. Uh-oh, I messed up, that's why. That's 1.1. Which means that this is 1.1. Which means that this is gonna be a different number. What the hell? That's even worse. Okay. 32.9. 32.9. Minus 6.5. Okay, this is the equation for line 1, I guess. No, it's not. Oh, Jesus. Okay. The late night debuff. This should, in the bracket, should always be 0.1. So 0.7 plus 3. Sheesh, 3.7. Oh well. I'm still under an hour. Okay, 3.7 squared divided by 1.1 squared minus 2. 9.31. 9.31. I hope this is right. More right. Because I don't want to keep going and fixing it if it's not. Okay, so P2. 1.2. So I'm going to plug in 1.2 to get my y value for P2. So 0.931 minus 3.7. 4.631. 4.631. Sig figs, screw it. Not at this time of night. I think you are supposed to keep as much as possible because none of these are your final answer. Oh my god, okay. Number 3. Slope number 3. 4.631 over 1.2, square it, minus 2. Okay, 4.631 to the power 2 divided by 1.2, square it, minus 2, 12.8. 12.89. I'm just gonna write 12.9. Okay, line 2. Y minus 4.631. Gosh, this is so tedious. Why did they make you start from so far away? Right. So that means that y, this is always going to be 0.1. So this is 1.29 plus 4.631. So P3 is going to be 1.3 and whatever this thing is. 5892. So the slope of tangent line 3 is 5.92 squared divided by 1.3 squared minus 2. This is stupid. How many marks is this? Almost there. Okay, so P4 is 1.4. So this is going to be 1.87 because again, this is always 0.1 when you plug in the next step. 5.92. 1.87 plus 5.92. 7.79 or something. I'm dying. Okay. One more thing. I would honestly not show this work. Just shove this all in a calculator. And it'd be really sad if I just was doing this completely wrong. Why is that so big? It's too late to go back now. We're just gonna keep going. I don't even know why I'm writing this. Here we go. So finally, using Euler's method. I don't even know what the question was. I know that I just stopped at 1.5. What is the approximate y value? Oh, approximate y value is this. 10.69? Whatever that is when you add those two numbers together. Okay, nice. How many marks was this? 4 marks? Jesus. I mean, yeah, a lot of this could be streamlined. And I didn't need to show the linear equation each time because, again, you're just going to take the slope, multiply it by 0.1. And then you're just adding the previous y value. So all of this could have been streamlined a bit more. I did not need to show all this work. But for you guys, because it's for you, I did. Ugh. Okay. Use this substitution to show this. Paste. Sure. Okay. What was the original derivative? Okay, so first off, so dy dx is going to be so we're going to do a bunch of substitutions, but first I need to find dy dx. So this is a product rule of v and x. So derivative of x is just 1, so this is going to be v plus basically x dv dx. Okay, so now I can do some substitutions. So this is going to be x squared times making a substitution for dy dx, x dv dx, and then we got vx squared minus 2x squared. Okay, okay. Sure, let's just keep things going. So I got x squared v plus x cubed dv dx. This is equal to v squared x squared. Ah, okay, I see it now. Okay, and then basically, because x is not going to be 0, I can just divide everything by x squared. So die, and then I move this thing over here so that I get what they want. Nice, okay, easy. I can't believe that's 3 marks. That's 1 mark less than the stupid Euler method. Okay, solving the differential equation, show this. Okay, so we're gonna solve this one, which is a separation of variables. So you got this. Okay, and then you got to integrate both sides. On the right side, you just have natural log of x. And then I'll just add the plus c. You don't need the absolute value because you know x is positive already from earlier. And then we need to integrate the other side. I guess it's time for partial fractions, right? Okay, so side thing, because I'm pretty sure this is factorable. Okay. So you get 1 is equal to AV plus A plus BV minus 2B. Okay, so easy enough. A plus AB needs to be 0. So A is negative B. This is from having no coefficient for V. And then we have A minus 2B is equal to 1. And then this is minus B minus 2B equals 1. So minus 3B equals 1. So B equals 1 over negative 3. And then that means that A, which is the negative version, is going to be positive. Okay. So then what do we got? A, which is the minus 2, 1. Well, they both have a coefficient of 1/3. It's just one is minus. This one is minus. So I don't know if this is going to be worth my time, but I'm going to factor it out. And then I'm just doing the integral of 1 over V minus 2 minus 1 over V minus whatever this is, plus 1. And then put the dv somewhere, something like this. Okay, so this is 1/3 natural log of V minus 2 minus natural log of V plus 1. And y is going to be more than 2x x. Whatever, we'll deal with this later. I just want to, I thought I could clean up the absolute value stuff right now. And then I'm supposed to show y, right? Man, this Euler method killed me. I'm so tired now. Okay. So V was xy, right? Okay, I think this is it. And then we need to find the constant, but they did tell us that way back in the beginning, x is 1, y is 3, right? That was our first point of the Euler's method. Because we needed some values so that I can get the constant. Okay, so 1 times 3 is 3, so this is natural log of 1 minus natural log of 4, natural log of 1 plus c, natural log of 1s are zeros, so we have 1/3 negative natural log 4 is equal to c. Is x always greater than 1 or always greater than 0? Okay, and then we now know what c is. Okay, and then these absolute value brackets don't matter because that's always positive. This is disgusting. This is what I don't like about HL papers, is like algebraic manipulation stuff. Okay, well, whatever. Okay, I don't like the 1/3, and then notice that, like, this is the overall game plan. We combine these natural logs together. We combine these natural logs together. Issue is, this would become a cube root. There are no cube roots in the expression they want. However, there is an x to the power 3. So I have a feeling we don't want to deal with these fractions. So first step, multiply everything by 3. And then that's how you get that cube there. So I currently have natural log like that. And then this side is going to combine. This goes here. And then you're going to have x cubed over 4. And then this is the thing that's bugging me, is that I don't know if I can just drop these. Because it's not always going to be positive, given these conditions that they give us. So what was it? Xy minus 2? When is this positive? This is the same as 2x squared minus 2 is positive. So when x squared is greater than 1, so when x is greater than 1, or when x is less than 1. But this is not part of our thing. Do I have to... And x is greater than 0. So do I have to split this up into 2 cases, and then they end up both being the same? What time is it? Ugh, I spent so much time on this. Whatever, you know what? I'm just gonna ignore it. And then we'll deal with consequences later. Okay, drop the natural logs. Okay, and then solve for y. I'm pretty sure. You probably get this. And if you don't, well, I don't know. I messed up. It is what it is. I'm dying here. I mean, you guys were dying too in the exam, so everyone just dies. Okay, so multiply this there, multiply this one there. Okay. This goes there, this goes here. So that I can factor out the y. And then I'll get 4x minus x to the power 4. And then I'll have x cubed plus 8. So y is equal to x cubed plus 8 over 4x minus x to the power 4? That is not what they say it is. Oh, what the hell? I have it upside down? Or I have it off a little bit. Because I have the 8. Hold on, I'm going to copy the question again. Oh my god, the last question is 12 marks? I'm not even on that part yet. Oh, I am on that part. I thought it meant like the very last question was 12 marks. Jesus. Okay, this is what it should be. So I have too many x's on my denominator, and I need one more x on my numerator. So I messed up my something somewhere. I don't have time for this. I got it close enough. I messed up somewhere. You guys can revisit it. I more or less showed you at least what you're supposed to do. Find the actual of y when x is 1.5. So plug it in. Plug in. Okay, 8 times 1.5 plus 1.5 to the power of 4. Okay, divide that by 4 minus 1.5 to the power of 3. $27. And then, okay, using the graph, explain why the approximation given is not a good estimate. What did we get for our estimate? Oh, 10.69. Oh, that's way off. Okay, using the graph. Okay, let's see what the graph looks like. So 8x plus this over 4 minus x to the cube. Whoa, okay. It has a vertical asymptote, and its vertical asymptote is at the cube root of 4. What is the cube root of 4? Ah, that explains things. Okay. So, there is a vertical asymptote at x equals cube root of 4, which is about 1.54, i.e. Your function grows asymptotically as x approaches 1.54. So again, in other words, Euler's is no good near 1.54, for example, for 1.5. So Euler's method kind of relies on your function not growing very quickly, because if your function grows like that, then hopefully you guys can see why Euler's thing is wrong. So if you start here, you get a little slopey, and then you would use this y, which is already going to have an error, and then you calculate the slope again, and then what happens is you're just going to propagate more error as you step out, because your Euler's method is a linear approximation and your graph is nowhere near linear. It's going to be asymptotic growth. So if you just keep doing this, it's going to get worse and worse. Like look at the huge difference in the true y value and then your approximation. Okay, that's it. I'm done. Overall, not that bad. I mean, I messed up somewhere here, but you know, whatever, close enough. Everything else seems okay. This one was tricky, the inverse thingy. Overall, I'd say it's pretty average again. Harder than paper 1 in my opinion, but average. Maybe slightly above average. Oh well. Good luck on paper 3. I'll see you on, I guess, Friday, 24 hours after Thursday.